Hello everyone and welcome back to my YouTube channel. I'm Gazahan. In this video, we are going to discuss about how to apply Venn diagram to solve word problem involving three sets. If you're new to the channel, please subscribe to get more videos. Let's get started. Before going to an example, let us analyze three intersecting sets in Venn diagrams. A region H represents A intersection B intersection C. A region E and H represent A intersection B. A region E represents A intersection B without C. G represents A intersection C without B. And the region G and H represents A intersection C. A region H and I represents B intersection C, whereas the region I represents B intersection C without A. And the region D represents A without B union C. Region F represents B without A union C. And the region J represents C without A union B. Each region of a Venn diagram contains elements that occur only in that particular regions. You can use a Venn diagram to determine the numbers of elements in the union of three sets. To analyze three intersecting sets, start by completing the sentry and then the two set intersection before filling the remainder of each set. Example 1. There are 38 students who study science, 40 study maths, 80 study chemistry, 24 study biology, 5 study maths and chemistry, 8 study maths and biology, 10 study biology and chemistry, 3 study all the three subjects. Determine the number of students who study maths and biology only. Determine the number of students who study maths and biology. Determine the number of students who study two subjects. Determine the number of students who study at least two subjects. Determine the number of students who study biology only. Determine the number of students who study chemistry only. Determine the number of students who do not study any of these subjects. We can answer this question easily by applying Venn diagram that represent maths by M, biology by B, chemistry by C. Now the Venn diagram is look like this one. The number of students who study chemistry is 80 and the number of students who study maths is 14 and the number of students who study biology is 24 and the number of students who study maths and chemistry is 5. So we can find this region. So 5 minus 3. This 2 is the number of students who study maths and chemistry without biology. The number of students who study biology and maths is 8. We can find this region by subtracting 8 minus 3, which is equals to 5. And the number of students who study chemistry and biology is 10. This region is 10 minus 3, which is equals to 7. This region is the number of students who study chemistry only. 80 minus 2 minus 3 7, which is equals to 6. We can find this region. This region is the number of students who study maths only. How we can get this? Simply we subtract 40 minus 2 3 minus 5, which is equals to 4. This region is the number of students who study only biology. 24 minus 5 minus 3 7, which is equals to 9. The number of students who does not study all the three subjects, let's say X. So to get this value, so from this, the values of X is 38, 36, which is equal to 2. Now we can answer the previous question. So number 1, the answer is 5. The number of students who study maths and biology only is 5. B. The number of students who study maths and biology is simply 5 plus 3, which is 8. The number of students who study two subjects is 2 plus 7 plus 5, which is equals to 14. Okay? That means, look, 2 plus 5 plus 7, which is equals to 14. And D, the number of students who study at least two subjects is 2 plus 3 plus 5 plus 7, which is equals to 17. The number of students who study biology only is the number of students who study chemistry only is 6. And the number of students who do not study any of these subjects is 2. Example 2. In grade 10 maths class, 27 students have a tablet, a computer, a cell phone. 50 students have tablet, 40 students have computer, 30 students have a cell phone, 5 students have a tablet and computer but not cell phone, 4 students have tablet and a cell phone but not a computer, 2 students have a computer and a cell phone but not a tablet. A. How many students have all three devices? How many students have tablet only? How many students have computer only? How many students have cell phone only? How many students have only one device? How many students have at least two devices? How many students have tablet and a computer? To answer this question, we must prepare a Venn diagram. Let's say tablet by T, computer by C, and cell phone by P. So the number of computer is 14. Number of students who have all the three devices, we don't know. Let's say X. The number of students that have tablet and a computer but not cell phone is 5 given, and the number of students who have tablet and cell phone but not computer 4. 14 minus 5 minus X minus 2. And this region is the number of students who have cell phone only. So we can get 13 minus 4 minus X minus 2. This region is the number of students who have tablet only. So how we can find 6 minus X plus 5 plus 4 plus X. So the values of X 2. Now we can answer all questions. Now this is 2, cell phone only is 5, students have all three devices 2, students have tablet only is 4, students have computer only 5, students have only one devices 10, students have at least two devices, a student have at least two devices is 13. How many students have tablet and a computer? Which is to 7. Example 3. 41 members in a sport club were surveyed to play all three sports. 23 play ball hockey and 24 play tennis. 80 play golf, 40 play tennis and ball hockey, 8 play tennis and golf. One member makes the refreshment and does not play any sport. Determine the number of people who play ball hockey and golf but not tennis. Determine the number of people who play ball, hockey, and golf. So to answer this question, we must prepare a Venn diagram and we must represent the sets by letter. So let's represent ball hockey by B, tennis by T. Let's represent golf by G. Now the Venn diagram I prepared is look like this one. The number of people who play ball hockey is 23. The number of people who play tennis is 24. And the number of people who play golf is 80. And the number of people who play all the three sports is 2. And one doesn't play any of these sports. And we can find this region, okay, this region, this, okay, how we can get? Let's see. The number of people who play ball, hockey and tennis is 40. So we subtract 2 to get the number of people who play ball, hockey and tennis only. These are 12. And the number of people who play golf and tennis is 8. So to find the region or the number of people who play golf and tennis only is, we subtract 2 from 8, we get 6. We don't know the number of people who play ball, hockey and golf only, so we represent by X. And the number of people who play tennis only is 24 minus 12 minus 2 minus 6, so we subtract from 24, this 12 to 6, we get 4. And the number of people who play ball, hockey is minus 12 minus 2 minus 6, we get 9 minus 6. And the number of people who play golf only is 80 minus x minus 2 minus 6, so we get 10 minus x. So to find the values of x, we must add 9 minus x, 12, 2, x, 6, 4, 10 minus x, and the 1, which is equals to 41, and solve for x. You will get the values of x3. The values of x, this x3 means the number of people who play ball, hockey and golf only. And the number of people who play ball, hockey and golf is x plus 2, which is equals to 3 plus 2, which is 5. We have answered the question. The number of people who play ball, hockey and golf but not tennis is 3. And the number of people who play ball, hockey and golf is 5. How? 3 plus 2. This is all about application of Venn diagram. If there is any doubt, question, comment, don't hesitate to leave under comment section. If you enjoyed this video, I hope you get some value from it. Please hit the like, share, subscribe and bell button to get all notifications. Thank you so much for watching. I will see you with another video.